Good morning, good afternoon, good evening, everyone. I can see people from different time zones have joined in. I hope you all are doing great. Welcome to the webinar on the basics of wireless presented to you by Konik Solutions. And my name is Roma Chauhan. I'm a corporate trainer at Konik Solutions. Uh, I have 10 years of experience prior to Konik. I have 10 years of experience in IT industry with various technologies. And I was lucky enough to learn and explore wireless. I was always looking for something which is very booming and which is very interesting. And thank God I came to wireless. I assure you that this 1 hour webinar will surely add up to your knowledge of wireless. And let me tell you that there are a lot of good opportunities in the market for wireless domain. I can boldly say that wireless is the future. It is always in demand and it can't be ignored to get your business running in the market or to give boost to your career. Any thing that you have, like wireless, is something which is very important, whatever you do these days. So, guys, in case if you have any questions or any doubt throughout the webinar, I would like you to just drop the questions in the chat box. It's there on the panel only. I guess it's on the right hand side of your panel. Please drop in your questions there at the end. When we start the Q&A session, I'll be giving the answers to those questions. So for now, I'd like you to concentrate on the presentation. Let me just turn off the camera. I hope my presentation is clear enough. You can talk to me on the chat box. I'll be giving answers to that over the chat box. All right, guys, let's move further. So before we start, let me introduce to our partners. We have partnered with renowned IT companies like Amazon, Microsoft, Cisco, VMware, Oracle, SAP. You can verify the authorization on the website under our partners webpage. Let's discuss a little bit about the agenda for today's webinar. In this session, we'll be exploring the importance of wireless technology. Will cover the wireless fundamentals and its technical framework. And finally, we will see a small demonstration to implement Cisco wireless network architecture, which I'm pretty sure everyone is interested in too. It's like a demo, small demo that I'll be showing it to you over a packet tracer. It's a simulator. Talking about wireless, as I've earlier said, that this is something which is very booming in the market and we must be aware of it. So, over the past few decades, wireless communication has reshaped the way we exchange information and data. Wireless is the future. The speed at which the world is changing, we are making a rapid transition from wired environment towards a completely wireless ones. Talking about the trends and shifts. So initially, so wireless technology, it has steadily become a bigger presence in most of the people's lives. So whether it's at home, work, stadium, or even in cars, people rely on wireless technology for information, entertainment, communication, and more. Originally, wireless was used for simple web browsing. So when I say wireless for connectivity, I'm actually trying to say that it's for simple web browsing or in email connectivity. So in case if you are on road or in airports, hotels, internet cafes, or shopping malls, it was good for that in those days. But now we can see that multiple devices can operate in connection to each other. So maybe your computers, smartphones, tablets, printers, your game consoles, media servers, scanners, etc. There are so many devices that, talking about the IoT also, there are so many devices. We have wireless enabled houses these days. That is something very interesting to know and learn. So, this IEEE, for that wireless, we have 802.11 standard, which I'll be going into a little bit depth little later. So let's talk about the current market needs. So when we say wireless solutions, wireless provides us solutions depending upon different aspects. So when I say it is very much convenient, I don't have to move around using those cables outside my house. I'm free to move with the single device. So all the notebook computers and many mobile phones, they today come up equipped with the Wi-Fi technology required to connect directly to the wireless LAN. Also, when I say moving from one place to another, that's some mobility. So employees can stay connected to the network even when they are not at their desk. It's so nice, no? You don't have to stick to your desk all the time. You can move around, you can go in your canteen and still you're working. You have access to your portal, whatever office stuff is there, you always have access to it. Secondly, setup is quite easy. So installation and maintenance of Wi-Fi or wireless network is quite easy. You don't have to run a physical cables through the location. So installation is very quick and it's cost effective as well. So it can cost less to operate the wireless LANs, which eliminate or reduce the wiring cost. We can't ignore that. Wiring cost and all is much higher. Also, reconfiguration of thing, or let's say expansions during scaling is very, very effective when we talk about wireless. Talking about the security. Now, of course, we need a robust security protections to our wireless data as it is, and it has to allow people to access your network only if it is accessed or it is allowed network. Secondly, talking about the scalability, as your business operation grows, you can simply scale your network very easily and effectively. You can expand with the existing equipments, right? So while a wired network might require additional wiring and all, but when we are talking about wireless, you don't have to get an additional equipment for that. So this is a market update on the basis of revenue. Wireless connectivity market is it's actually rapidly growing space with a growing demand for cloud computing and related technologies. The market is expected to continue to grow in years to come. So according to one of the reports that I found on Market Research Future, the CAGR, the compound annual growth rate, is going to reach 214.3 billion by 2030 during the assessment time frame. So it's country-wise, if you can see, and it is continuously growing. Now, this particular chart that I've got is this bar graph thing is actually showing you the consumptional growth across the globe on the basis of the Wi-Fi technologies that are available. So it can be Wi-Fi, it can be Zigbee, or it can be others. Now, talking about Zigbee, it's a wireless protocol. It allows the smart devices like your light bulbs or your smart locks, the motion sensors, door sensors, to communicate with each others over a personal area network. And when we say others, it includes the cellular devices, the Bluetooth, the infrared LTE, etc. So even here you can see that technology-wise also it is much growing with years. Let's talk about a little bit of history so that you should be aware of it and it should create an interest to it. We can see that people from different backgrounds have tried to develop wireless and they have contributed a good part into wireless. So when I remember I wasn't born at that time though. 1G actually started in 1983. I remember my parents carrying a brick-sized phones in those days. So why would the at that time voice calls with those big mobile phones started in 1983, and then 2G started in 1992 when SMS and email services were started, providing 114 kbps of data rate transfer. So and 2003 we started with 3G where only web browsing, simple web browsing started with allowing us 42 Mbps of data rate transfer. 2010 we started with video and online gaming 4G, right? So we that was a very interesting phase though. And 5G has recently started in 2018 where we see autonomous cars, AR, VR, virtual reality, and IoT allowing us 1 Gbps of speed and rate data transfer. So 6G started in 2020, right? Let's look at a little bit into details of it. So discovery of electromagnetic field started by Michael Faraday in 1821. Before him there was one person named as Oersted. He discovered by accident that electric current it creates a magnetic field in 1820. So it actually started in 1820, long back. In 1901, Guglielmo Marconi and his assistant, George Kemp, he confirmed the reception of first transatlantic radio signals. And it was something very interesting. They found that they really confirmed that, we are recepting the radio signals. They tried this over an island. And the FCC, the Federal Communication Commission. Okay. And here we are talking about the history. All right. So I was talking about the Federal Communication Commission, and it was effected in 1934 with three divisions. One was for broadcasting, one was for telegraph and telephone as well. Then we have FHSS, the frequency hopping spread spectrum. Transmission is started in the year 1942. It's the method to do repeat switching of the carrier frequency during the radio transmission. So basic idea was to reduce the interference and to avoid the interception. In 1997, we started with IEEE. It actually started the standards ABGN. We'll look at it little into details. So Wi-Fi Alliance, it's a non-profit organization that owns the Wi-Fi trade, the trademark, which you see Wi-Fi is written. The logo is actually owned by Wi-Fi Alliance. Now, these are the couple of great individuals who actually contributed to the wireless domains. So the Hertz is, when we say frequency unit, Hertz is named after the German physicist Heinrich Hertz, who demonstrated the existence of radio waves. This guy, Guglielmo Marconi, was talking about him, who was an Italian inventor and electrical engineer. He is known for radio wave based wireless telegraph system. So they did using the Morse code. If you research, you'll find much knowledge about it. Then we have a priest over here, a Brazilian priest, Roberto, who transmitted the human voice wirelessly over the distance of 8 kilometers in the year 1899. We have an Indian guy over here. I'm specifically saying that because I'm Indian. So this guy, Jagdish Chandra Bose, he's called as the father of radio sciences. The first millimeter wave communication, or we say Adrishya Alok, invisible light, was discovered by Jagdish Chandra Bose. And then we have an actress over here, Hedy Lamarr. She was inducted into National Inventors Hall of Fame for her technology, for the frequency hopping technology that she came up with in the year 2014. She was, for her achievement, she was named as the mother of Wi-Fi and other wireless communications like GPS and Bluetooth. She's a very nice actress. If you see her movies, they are very interesting. All right, so we have the father of Wi-Fi here, Vic Hayes, and Vic Hayes, his role in establishing IEEE 802.11 standards for wireless LAN has led him to be referred as the father of Wi-Fi technology. And he was working in IEEE in those days when he introduced these standards for wireless. There are good organizations that we should talk about. I already told about Wi-Fi Alliance, and it helps the companies to come up with the equipments. All the certification and all is done by Wi-Fi Alliance. Then these are few organizations that you'll always come across when you learn or when you work with wireless. So it's Wi-Fi Alliance. I told it's a certification testing for the wireless equipment. We have FCC, who regulates the frequencies, who decides which frequencies has to be used for which devices, for which equipments, and for what purposes, the power levels and the transmission methods, etc. IEEE, again, IEEE does the standardization thing. So internet standards are done in RFCs by IEEE. Then we have an Indian organization here called as TRI, the Telecom Regulatory Authority of India. It's a regulatory body by Government of India, and it is the regulator for telecommunication sector throughout the India. Others you already must be knowing, Zigbee, LoRa, and all. They are again non-profit organizations to support the wireless frequency or wireless frequency technology rather. Now, this is a beautiful website that I always refer to. So whenever you buy any Wi-Fi device or any wireless equipment, you can simply go onto this page and you can just type in what device you have purchased in order to see the security aspects, in order to see the standardization, in order to see which certificate, what will be the connectivity, will it support that and all. So let me give you an example of an access point maybe. So let's go for this only, access point 314. It's by Dell. So whenever you want to learn more about any wireless device, you can simply type the keyword and you'll get all the details of it. So let's check for this. It's by Dell Technologies. And can you see the access security? You will get all the details. Though it is there on the box or the manual, but you can still deep dive using this website. So wifi.org product finder. You can always refer to this website. It's really good website. So, all right. Let's talk about a little bit technical things. So the wireless fundamentals, we'll talk about a spectrum and everything. So let's just jump into it. Talking about the spectrum. Now, spectrum refers to the entire range of frequencies, right from the starting frequency, which is the lowest frequency, as it's not mentioned over here, but I'll just note it down for you guys. Let me just turn on my pen quickly. So it starts from 3 kilohertz That's the lowest frequency on the wireless spectrum, or rather the spectrum itself. And we have 300 gigahertz frequency. That's the highest frequency. That's the ending frequency on the spectrum. Just it's the entire range of frequency right from the starting to the ending. Spectrum refers to the invisible airways that carries the wireless signal to make the communication and transfer information as possible. Now here you could see ultraviolet. Now this is the visible light, right? Our wireless thing is somewhere here. I have just highlighted this point. It says 2.4 gigahertz and 5 gigahertz. These two bands we are going to utilize for our wireless transmission. Okay, so this is about the wireless spectrum. Now, what about frequency? When we talk about wireless, we are always talking about frequency. Frequency, it actually determines how often a signal is seen. So technically, we can say number of cycles per second. So if it's one cycle per second, it's 1 hertz, right? Hertz is the unit named on Heinrich Hertz. Now, see, in this first cycle, I can see 2 cycles per second, right? At the end, it is written 1 second. So if it's 2 cycles, it's 2 hertz. If it's 4 cycles, it's 4 hertz. At the end, I can see 7 cycles. That is 7 cycles per second. That is 7 hertz. That is frequency, number of the occurrences you see at a particular time, and that's frequency. Let's talk about wavelength. What is wavelength? When we talk about wireless, these are the terms we come across several times. So now the signal generated in the transmitter is sent to the antenna. Okay, the electron movement generates an electric field, which is in the form of a wave, electromagnetic wave, right? The size of the cycle pattern is called as a wavelength, right? Higher the frequency, higher the number of cycles. Now here I could see a lot of cycles, right? There are a lot of cycles. So that means it is higher, the frequency is high, right? But it has a shorter wavelength. The wavelength size is shorter, right? And lower the frequency, less number of cycles. Low frequency, less number of cycles. It has a long wavelength, right? We'll see the applications as well. What is the use of high frequency? What is the use of low frequency and all? Talking about the amplitude. Amplitude is the vertical distance. Now here I've just mentioned the distance, the vertical distance or the height of the wave from the neutral position. Okay. For the same wavelength and frequency, different amplitude can exist. It represents the quantity of energy injected in the signal. This value is usually regulated as it affects the receiver. Amplitude, it affects the receiver end. Now, when we learn wireless, there are some issues that we come across, like at your house also, when you're working, you see that, sometimes you don't get the signal. And there can be different issues. So indoor also, we have some issues while we are placing the uh, towers outside, the wireless towers. You see that there are outdoor weaknesses as well. Let's talk about indoor weaknesses. So the very first and very common thing that is happening in wireless technology, that is issue, is absorption. It actually takes away the energy from the wave. This energy is dissipated in the form of heat in the obstacle. So when 100% energy is taken, the wave actually stops, right? It's actually going to reduce the amplitude. Just now I told you about amplitude. It's talking about the energy, right? So the effect of absorption is to reduce the amplitude, and signal therefore is less powerful. You face issues. So, like I placed a paper. If I place a paper, there is still a less absorption. Wood will be a little more. So if you have a concrete wall, of course there'll be less transmission post that. And it's if it is iron, when you move across an elevator or a lift, you always see that there's no signal. That's the reason. It's absorption. Okay, so next is reflection. So part of the energy is reflected and part of it may be transmitted. So some part of it will get reflected. So the angle of reflection is same as the initial angle. Now, in case if there is any object in the room that you are working, you cannot see that, but then this is the case. There will be reflection. So there'll be delayed multiple copies of the same signal hitting the receiver. Now it depends upon the wavelength and the position of the receiver as well. So reflection is happening. Now amplitude, it has no impact on the so reflection, it doesn't have any impact on the amplitude though. but the angle of reflection, it is going to cause a problem during the transmission. Talking about the multipath, now it occurs when the signal reflects from any particular surface. Okay, now here I've placed one mirror and the other is an object. So my signal would get reflected and it'll go back to the receiver end. Now, again, there'll be copies of the same signal, right? So multi-path issue is happening during indoor transmission. Free path loss, it's easy to understand. As you move farther from the source, you see that there is issue with the signal, that is free path loss. Closer the devices, closer the wireless equipment is, you get the best signal. You move across, you get less stronger signal. Talking about the outdoor weaknesses, refraction is the one. Okay, so it occurs when the wave passes from one medium to another medium, right? There are minor effects on the indoor networks as well, but you see it out at the outdoor range, you see it effectively, the refraction, it happens. Now, line of sight is the next one. Again, it is very necessary to have a good signal transmission. Line of sight is very important for the good signal. So what you do is the visual obstacles may or may not prevent the radio line of sight. So basically you see two towers here and at the center, if it's not within the sight, it is going to cause a problem, right? So the towers are placed in such a way that it is within the visual length or vision. You should be able to see it, right? The next one is scattering. It occurs when the microparticles they deviate in multiple directions. It affects the shorter wavelength more than the longer ones. It can weaken the signal. It can be dust. It can be the fog. It can cause an issue to your wireless signals. Then we have a Fresnel zone. It determines the area around the radio line of sight where the reflection have most negative impact on the signal. It should be least free from the obstacle in the line of sight. So it's all talking about the line of sight and placing the towers, the wireless towers. So these are the wireless weaknesses that we come across while we are working over wireless devices or wireless technologies. Now, talking about the topologies, wireless topologies, there are majorly there are four wireless networks, four types of wireless networks. That is wireless LAN, MAN, personal area network, and wide area network. It differs as with the size, range, and the connectivity of requirements. So let's talk about PAN. That's a personal area network. The standard for that by IEEE is 802.15. It's actually used for Bluetooth version 1.2 and 2.0. Then we have wireless LAN connection. Wireless LAN connection is a local area network that we have. The range that it offers is less than 100 meters. Then we have city-wide network. If you're going to span across your network across the city, it will be a wide area network, and it supports this. There are different standards for that. So it can be 802.11a, b, g, n. It can be anything. We'll learn that as well. We have a metropolitan area network for wireless, which is city and beyond. So we use my WiMAX for that, which is more than 5 kilometers. Talking about the modes, like if it is ad hoc mode, your wireless is an ad hoc mode or infrastructure mode. So now talking about the ad hoc mode first. So when we say that my network is ad hoc, because it doesn't really rely on any pre-existing infrastructure such as your routers in the wired network or any access point in the wireless network, right? So if a user has two laptops and he's in any hotel without any Wi-Fi, there can be a connection directly to these two devices using ad hoc mode to create a temporary Wi-Fi network without the router, right? Of course, it requires the wireless network adapter for that. Then we have infrastructure mode. The word itself says that you need an infrastructure for that. So it's a wireless network framework. It has a central access point, or central WLAN access point, or a router at the heart of the network, right? Ad hoc mode, in ad hoc mode, each node transmits the data directly to the other node without the access point. And in infrastructure mode, all communication needs to go through the access point, which connects the wireless. So my access point here, okay, it's actually acting as a bridge between the wired network and the wireless network. It's acting as a bridge between a wire and wireless. When we see the demo at the end, you will understand this into little bit depth. So let's move further. Okay, SSID is the term that you always come across. It's a technical term for the Wi-Fi network name. So whenever you set up a wireless home network, you give it a name. You give a name to it, a friendly, user-friendly name to it to distinguish it from the other networks in your neighborhood. And you always try to keep it as unique. But if it is not, still it's not a problem. You'll see this name when you connect your devices to the wireless network. It can be anything, right? So SSID is nothing but a name. It stands for service set identifiers. It's the friendly name given to your network. Okay. All right. This is something very techy and it's very interesting though. So there are 14 channels. I hope you could see this image. There are from 1 to 14. We have 14 channels designated for the wireless networks in 2.4 gigahertz band. We have 14 channels and we have 42 channels in the 5G network. We have 42 channels in total in the 5 gigahertz frequency band. The 14 channels in 2.4 bands are spaced 5. The distance between these two bands will be 5 megahertz apart. Okay. The protocol requires 25 megahertz channel separation because we don't want any interference to occur. Now, talking about the interference occurs when the two or more different signal are received at the same time, right? For this reason, only channel number 1, 6, if you could see, 11, these channel are typically used to avoid the interference. Okay. It's typically used in US. Okay. In rest of the world, the 4 channels like 1, 5, 9, 13 are recommended. Right. The 2.4 gigahertz frequency band is heavily used because most devices can operate on this particular band, right? 5G band is actually 4 frequency bands. It's 5.1, 5.3, 5.4, and 5.8. The 5G band has total number of 24 channels with 20 megahertz bandwidth available. Now, see, we are placing this channel, we are utilizing this channel because we don't want interference to happen, right? And to avoid that, we use a honeycomb pattern to place our base stations. So honeycomb configuration of multiple base stations will look like this. So if I say in US, we have 1, 6, and 11, and channel number 14 was also there, but it is used specifically in Japan. If you are in Japan and if you are using 802.11b, you can use that channel number 14. So you are going to place it in a honeycomb pattern just to avoid the interference. So next to 6, you have 1 and 11, right? Everywhere you see this kind of structure, right? So it's a pure thing. There's no interference in it. Okay, then we'll talk about antennas a little bit. Okay, you could see polarization happening. So polarization of antenna is, if I have to define it, it's the direction of the electromagnetic field produced by the antenna, right? As the energy radiates away from it, these directional fields determine the direction in which the energy moves away. Now, see, we say it's an electromagnetic wave, right? We have learned that electric field creates a magnetic field, and magnetic field creates vice versa, electric field. So it is always in a perpendicular shape. So let's say it's a electrical field, and this is the magnetic field that is generated, and this is the polarization, circular polarization that is happening across my antenna, right? There are different antenna types that we use depending upon the usage and depending upon your requirement though. So we'll see a couple of antenna types here. So most commonly we have 2 types. One is omnidirectional and this directional. So when we say omnidirectional, the word omni means everywhere. So it's going to broadcast your signal, your antenna is going to broadcast your signal everywhere, right? So let's say this is a dipole antenna in which we have this pole-like structure, and it's not going to emit any signals here. Okay, though we say omnidirectional, but there's no emission of signals from here. So it's like this, and hence it is forming a donut-like structure, like this. A donut-like structure is formed, right? It is great for general coverage and is it's cost effective, I'll say most cost effective option available for general coverage. It provides a central location, and yeah, this is the good option, omnidirection. Second, we have a little bit costly option that is a directional one. So in directional, we have a couple of types available. So we can use a patch antenna, we can have Yagi antenna, giving a particular direction, right? Directional antenna are they are best for getting signals to a specific area. If you want to give signals, if you want to send signals from one building to other building, you have to give some direction. So it will look like this. So we have omnidirectional and underdirectional. These three options are there. So you can use a dish antenna as well, right? Because it is going to give you a signal in this format, parabolic thing. Right, so these are the antenna types. Let's talk a little bit about the Wi-Fi standards and its features. Okay, so see, due to increasing number of the connections these days, like many people experience slower speed, unreliable connection, right? So to improve these issues, new standard of Wi-Fi has been developed by Wi-Fi Alliance. So after a couple of years, you see that they come up with some different standards with better performance and better no interference kind of things. So here we are. So they started with 802.11 in 1997, supporting the speed of 2 mbps, and the range they offered, the indoor range they offered was 10 meters. Then 802.11 standard, it started in the year 1999. In fact, in 1999, they started with 11A and 11B both. Okay. 11A, it worked on a 5 gigahertz frequency, supporting the data rate of 54 mbps, up to 54 mbps, and the range was 30 meters. 11B was working on 2.4 gigahertz, providing you 11 mbps of data rate transfer. Then we have 11G, 802.11G. It started in 2003, in the year 2003. It supported up to 54 mbps of data transfer, and it worked on 2.4 gigahertz. 802.11 standard, it started in the year 2009, right? And it supported almost 450 mbps to 600 mbps. Okay. And it was supporting two frequencies, 2.4 and 5 gigahertz. Okay. And it was backward compatible, as in if you have one device working on 11N, and if you have another device working on 11G or B or A, it was still, you will be able to do the transmission with these two devices. So we say it's a backward compatible device, 11N standard. Now 11AC, it's having a very high throughput. It started in the year 2013, right? And it works on the frequency 5 gigahertz. Then we have 11x, which started in 2019, which supports both the things, and it was again backward compatible with 3 Gbps of data rate transfer. The range was 35 meter in both these cases. Okay, now that we have seen how the standards work, it is always good to know the security aspect as well. Because if you create a network, if you don't secure it, if it is getting hacked, all your efforts are going to get in vain, right? So, of course, security is playing a vital role, right? So they started with wireless 802.11 as the first thing. They came up with a wired equivalent privacy, that is web. Okay. Now, when we say wired equivalent privacy, that means it is as good as the wired ones, though it was not. It was developed in the year 1999 when they started with 802.11 standard, right? And of course, it was having a lot of loopholes. So they moved to WPA2. The WPA, it was developed in the year 2003 by Wi-Fi Alliance. Okay, web was started by IEEE, and WPA was developed by Wi-Fi Alliance. Now, again, as I told you, there were lots of vulnerabilities with web. A new protocol has to be developed. It is done by Wi-Fi Protected Access version 1, and it was using 256-bit encryption. Okay, so basically, it provided two modes for WPA. Now, it's not mentioned. I'll just stick it here. So it was supporting for enterprise. You were having EAP, and if it is personal, it's for personal mode. We used to use PSK, pre-shared key thing, right? So again, with time, they found that there are vulnerabilities with WPA as well. Then they came up with WPA2. It was developed in the year 2006. Okay, it was the advanced version of first WPA. Vulnerable parts of WPA became stronger in the second version. And the current one is WPA3, the last developed security standard. Okay. And WPA3 offers improved authentication and improved encryption. It will be used for your with more technologies like your 802.AX standard. And it is mandatory for Wi-Fi 6 as well, the upcoming one. So yes, WPA3 played a very vital role. And if you see on your devices, if it is WPA3, you should now know that it is much better, and you should go for that device or an equipment that you're looking for. Let's go for a small demo that I was talking about, and how you set up your wireless, because setup like setting up the wireless network on a virtual platform, it's difficult. So for that, I'm going to use a simulator by Cisco. So it's a Cisco packet tracer. Okay. So now I'll just explain what all devices are these. This is the switch that I'm going to use. This is the PC. Okay. And this is the wireless controller. So basically, I'm going to use this PC to access my wireless controller. From there, I'm going to manage this device. Okay. For that purpose, I've taken this PC. This is the DHCP server. So basically, I took a server and I configured it as a dynamic host configuration protocol. So in your wireless devices, you don't go ahead and put in the IP address manually, right? So there's something which is giving it automatically. This is the server that will do the best. And this is the wired network. You will see that, okay, Roma, you're telling us wireless, but this is a wired network that you're showing. So for this, let's change this topology a little bit. So let me bring up with some device that will help me to make it wireless. So these are the wireless devices. I'll go for any one of these access points. So I'll take this access point. I'll connect it because I'm saying that my access point is acting like a bridge between the wired and the wireless networks, right? So let me just put it on. So I've taken this. It's a very good access point. I simply have to connect this power adapter to it. I'm so sorry. Let me just connect it again. Yeah. So, all right. So, doing fast forward. Yes, it's all green enough. That means the setup is done. Now, what I have to do is let me bring up any wireless device. So, let's take a laptop. Okay. And let's take one smart device, smartphone as well. So let me configure this laptop. So basically, okay, let me show you one thing before we start. So on this wireless controller, I have created SSID. Just now I told you about SSID also. So I have created an SSID. I'll show you how it looks. Just a second. All right. So I'll go on the desktop. It's a virtual thing. It's a simulator. So it's as good as having a PC. Okay. So I'm going on a web browser and just I'm going to type the wireless IP address, the IP address that I gave to this wireless controller. So I'll just put that address 172.1.150. Okay, so I just went on the computer, I've opened the browser, and I'm now trying to log into the wireless controller. This I'm doing it on the PC, okay, not on the controller. Okay, it doesn't have any interface as such. So you have to connect it using the cable, okay, or remotely. So I'll just log in. I've given, while you do this first time, it'll ask you for setup. At that time, you put in the username and password. So for now, I'll just put in the details. It's Cisco 123. Once you log in, you'll be able to see the wireless controller panel. Okay, it's a portal-like thing. It has so many options, you see. This wireless controller by Cisco is actually going to help me to do n number of things, right? Right, how many devices are connected. So right now only one port is having a connection of wireless. So let me show you. This is the only one port is getting utilized. That's why it is showing me that, right? Okay. And which devices, when it was started. So I was just testing. So it's showing 1 hour before we see which standard it is supporting. Is it up, right? How many clients are connected? As of now, there's no connection, right? No wireless connection. So it's showing zero. Then this is the place where I've configured my SSIDs. So I'll just show you quickly how it looks. Okay, so the name that I gave for my SSID is CCNA. I have used WPA2 authentication and I've given a password as well. So now let's try to connect our wireless devices to this access point. So I'll go on this laptop. Okay, so before we start this laptop, I'll have to connect the adapter to it. So let me remove this cover. Okay, Okay, it's saying power it off. Okay, now I'll just remove it. Place this wireless interface. Okay, and turn it on. Okay. Now I'll go on the configurations. Now I could see wireless option over here. I'll simply put the name that I've given. So I've given CCNA. Okay. And then I'll give some password to it. So the password that I actually did was key 12345. Okay. That's it. Now it should be able to connect to this network. Can you see? It got the connection. Let's do it on the smartphone as well. Now, smartphone by default it comes up with the wireless thing, so no need to go for any adapter or anything. Simply put in the SSID, the name, and put the password. So it was key 12345. That's it, and you'll be able to see, yes, the connection is happening, right? This is the simplest, I have just shown you the simplest configuration over a simulator. The way we turn to enterprise, it becomes much complicated. So it's different, you have to go for details in that case. But this was a short demonstration how you connect your wireless devices to the access point and how you control it over wireless controller using your PC or any other connection. All right, so guys, let me see if I've come up with any questions. So if you have any queries related to the wireless or whatever I've taught, you can just post it in the chat box. Now, one more thing, guys, there's a feedback form link that will be posted in the chat. Please fill the same so that you'll get the participation certificate. Okay, you'll be getting a certificate for participating in this webinar. So please fill in the feedback form. I guess we have the feedback form in here. Just a second. Let me just check. Okay, I can see a lot of questions coming up. Okay, is Aruba, Lumika is asking, is Aruba part of your partners? Okay, so yes, we do have partnership with Aruba as well, and we are going to come up with like Aruba courses as well. Okay, and what else? All right. Is it possible to get the presentation where section is over? What? Okay, you want the PPT. Okay. I don't think so. I can do that. All right. Okay. There was some voice issue at someone's end. Okay. I think Abhishek was asking, can you give one example of outdoor weaknesses, refraction? I guess I answered that already. Water vapor change. Okay, there was a great communication happening while I was teaching. I could see people are talking to each other and replying. That's really great. I could see that people are keen towards wireless and they are aware of the 5G technologies. Which security standard do we use for 5G technology? Yes, we come up with WPA3. I guess I've covered the security topics as well. I guess Fatima from my backend team has given you the feedback form link. Guys, please do fill in this feedback. I'll just put it again. This will give you the participation certificate. Kindly fill in the form, okay? And all right, so we have few courses by Koenig Solutions. I'll just drop in the link of our website. It will surely help you. Just go into it, go through the website and see what all options that we have. Okay, you can just have a customized course as well. If you are a working candidate, if you're a student, you can definitely go for any of those courses. Let me just put the website link. You can just deep dive into it. I'll just drop in the chat box itself. Okay, I hope you guys are filling up the feedback form. Okay, Patrick, so sorry you're asking for a copy of presentation. I guess we have your email IDs as well. So if possible, we'll drop you an email address. I'll have to talk to my concern team for that, if that's possible. Okay. And guys, you can just go through the feedback form. Please fill up so that you will get the participation certificate. Also, I have added the website link for you to just go for the website, how much, courses, how many courses we have, and we have a broad area for that, with as I've shown you the different partners that we are having. Okay, thank you so much. I can see people are dropping their email IDs as well. Guys, when you join email IDs, we do have that. So, okay, where is the feedback form? Let me just drop again. Just a second. Okay. Thank you so much, Gurdeep, for joining. Thank you so much, guys, for joining and giving me your time. I hope it was fruitful and you have learned something from this webinar, and it will surely help you to, move across the world with the better understanding of wireless. All right, guys, I guess you are dropping the email IDs. We do have your email IDs. Just fill in the form. Okay, this is the form. Thank you so much, Akash, for your comment. Thank you so much, Marcus. I can see you liked the webinar. It was, thank you so much for that, for your comments. All right. I can see a few more email IDs coming up. Guys, we do have your email IDs. You have to fill in the feedback form. You will get the like certificate for that, participation certificate. Thank you so much, Nina. Thank you so much. Thank you so much. Yes. Thank you so much, guys. Have a great time ahead. Have a great time ahead. Thank you so much, Pushpendra. That means a lot. Thank you so much, Lee. Thanks, Sam. Thanks, Sam. Thank you so much, Mohammed Fofana. Yes. Thank you so much, Karan. Thanks, Davis. Thanks, Chris. It means a lot to me. I just expect you guys to learn more about wireless. It's really great to just deep dive into it. It's very interesting field. Thank you so much, Sandra. Have a great time ahead. Thank you so much, Abhishek. Thanks a lot, guys. Thanks a lot. Take care. Have a great time ahead. Thank you, guys. Thank you so much. Thank you so much, Mario. Yes. Thanks, Murthy. Yes. Thank you so much, Dishan. I hope you guys are filling up the feedback form side by side so that you'll get the participation certificate. Thank you so much. Yes, ma'am. Thank you for confirming. You will be getting the participation certificate on your email IDs. Thanks for confirming. Thank you so much. Okay, you didn't got the feedback form. Let me paste it again. Here it is. In the feedback form only, you'll be able to add your email IDs as well. Yes. Yes, Fatima, you're right. You'll be able to download your participation certificate. Within few hours, you'll get it on your email ID only. In the form itself, you can see that email ID. You have to enter your correct email address. You will get the link. Phone contact, I'm not sure if I can share my personal contact, but yes, let me just share the email address of our company itself so that you can get in touch with them anytime that you want and you can get more information. Just a second, let me just drop the email ID as well. Okay, so here, okay, can we get the recorded videos? Okay, let me get back to you over the email IDs only. So see, this is the email address info@conicsolutions.com. There's a hyphen in between. So please make sure that you put in the hyphen and you can write to us at any time, any query, any concern, you can just get back to us on this email ID. Okay, website is there in which you will get a lot of information. But in case if it's something additional, you can just write at info@conicsolutions. Yes, you can. Yes, if you have received that, the recording, okay, I guess Fatima from my team is saying that recording will be updated within 24 hours. You can leave the recording, okay, on the links, all right? So, yes, you'll be getting that as well. That's the best part, I guess. All right, I hope you all have filled up the feedback form. You will definitely get the participation certificate and the recording link as well. Okay, guys, I've already shared the website link as well for your information, how you will see the training and how you will see the courses. But let me just share my screen quickly and let me show you because few of them are having doubts like how to, find out the courses, appropriate courses for your learning purposes for wireless. So let me just share my screen again. I hope you can see my screen, right? So these are the wireless training and certification courses which are available. So it can be one-on-one. Again, as I told you, there are flexible dates available. You can have 4-hour session instead of 8-hour session, right? You will get the video recording of the live session that you are attending. Again, you can have destination training at various locations provided here. And these are the courses and certifications for wireless. You can learn and you can give a boost to your career as well as your business. So these are the courses available. I've just dropped the link as well. I'll just do it once again. Training link. So wireless courses that we have. You can see the courses available. Duration also, it you can have flexible duration. So you can sit for 8 hours. You can go for 8 hours training. If you can sit for 4 hours, if you are a working person, you can have that sessions as well. You can write to us at info@Koenig Solutions in case if you have any queries, or you can fill up this form as well. In case if you want more about any of the, you can simply fill up this form, put your email address correctly because that's where we're going to contact you, and your phone number as well. And you can fill up this form, submit it, you will get more details. Okay, few of your queries are answered here as well. So you can always check this links for more information. Guys, I guess remaining of you have filled up the feedback form. Please do check in your email addresses for the participation certificate and the recording. If there are no more questions, we can end. Have a great time ahead, guys. Learn more wireless. Just check in our website. Yes, have a great time ahead, guys. Thank you so much. Thank you so much. I don't get the email. Okay, okay. Surely you will get it. It says couple of hours you'll be getting a feedback form. Sorry, you'll be getting a participation certificate once you fill in the feedback form, and you'll be getting a recording link as well. So don't worry, you will get that. Okay. Just check your email address once after a couple of hours. You will get a downloadable participation certificate. Thank you so much. Thank you so much.